Dear student, welcome to this very short video related to chapter 8 and 9 of the course. The very small chapters where I will really restrict the content to its minimum. I skipped chapter 7 since you have a lot of other courses related to safety, and especially a course from last year was a very interesting one, I think, for on board to use on board of gas tankers. So I will not spend any time on this, but of course all these safety items are part of this course. In chapter 8 I will briefly repeat. Yeah, it's a repetition. I presume that you have seen that also in the safety course of last year, namely the ship-shore interface, the interaction, communication between the ship and the shore related to the gas handling transport. That is what we will do here. There is, of course, a direct contact before we start the operations with the loadmaster, where we'll discuss all the different parameters related to the loading or the discharging operation. That's everything about temperature, pressures, ESD, mooring, and so on. What to do in emergencies, how the quick release can be operated, who will operate that, and who will activate it, and so on and so on. Names and roles of the responsible personnel, who is responsible for the operation on board, who is responsible for the operation at the terminal. The cargo and vessel equipment is conformed to the requirements. What are the connections? Do we need reduction pieces? Do we need to connect reduction pieces before we can connect the jigsaw? Terminal equipment is confirmed. Condition of the cargo tanks and or cargo tanks. What is the actual temperature of the cargo? What is the actual pressure in the cargo tanks? What is the cargo quantity that you need to load or that you need to discharge? It's better to discuss this beforehand and not afterwards, because then it's too late, of course. Then everything regarding to temperature, rates, and especially the step up for the rate, and which rate will you start in order to cool down the lines, to check for the leaks, and then the gradual increase. The sequences, which tank will you load first, or in which tanks will you load first or discharge first? Pressures, your maximum pressure, the use of the vapor return, under which conditions will you use the vapor return? Will you connect it, or will you only connect it and then keep the valve closed? Which conditions will you open these vapor return? Ballast operations and so on. They will ask you about the previous cargoes, especially related to contamination, of course. Let's say that you arrive at VCM and your previous cargo was ammonia. They will definitely check the cargo for ammonia contamination. That is for sure. Appropriate cargo hazard sheet should be available and posted. Have manifold loading arm match, this is reduction piece. Review of the port and terminal regulations if there are any special requests from the terminal side. Emergency procedures, other relevant info, safety checklist, but I think that you discussed already in the other course. Then the purging of the loading arms. We have the purging before and the purging after the operation. In this context, it means that you should remove the hazardous material and replace it with an inert or safe atmosphere. That is after the operation, before you disconnect it. But before you start the loading or discharging operation, you can also do a check of the loading arms, and you can check whether the loading arms are well gas tight connected. With the purging of loading arms, we mean in fact after the operations, before we disconnect it, so that the disconnection can take place in all safety. That's why we call it purging. Purging and gassing up is not the same. Gassing up is bringing the space in what we discussed, the tank under an atmosphere with cargo vapors. Purging is just evacuating the hydrocarbons present in a tank. You know this Jackson from the course of Captain de Bare, I presume, and these are the limits in which this Jackson can operate. It might be that when the normal operating zone is exceeded by the arm due to the displacement of the ship, that an alarm goes off, and even at a certain moment that there is an automatic disconnection and release of the mooring ropes and wires. Before operations, we can perform a nitrogen test of the arm connection, and this is normally done on board of LNG. We don't see it that often on board of LPG since there's no nitrogen available on board, and most of the time not available ashore. How is it done on board of LPG? It's just done by simply slowly starting and verifying whether there are any leaks. On board of LNG, this is done by a pressure test. So that means we pressurize nitrogen into the lines while you keep, of course, your manifold closed. The shore pushes the nitrogen from their side, increase the pressure, and they will check for leaks at the manifold valve and at the connection, of course. When it has been proven tight, your manifold will be depressurized and the transfer can start. After the operation, we need to purge the loading arms. The purging can be done with or hot gas or nitrogen. Gaseous nitrogen, of course, not liquefied nitrogen, gaseous nitrogen, vapors. Purging with hot gas, that is on board of an LPG, we will start a compressor, and the discharge of the compressor we immediately send to the manifold. And in this way, we push the liquid, which is still remaining into the lines, we push it back towards the shore. On board of an LNG, we can do the same, but this time with compressors, or we do it with nitrogen. But when you do it with nitrogen, you know that you are, of course, introducing nitrogen also into your tanks, which you don't like too much. But okay, a small quantity is allowed. I want to add here that the way to get rid of the liquid inside the loading arm can be done by pressurization. So that means you close the discharge valve or the discharge valve from the shore side. You increase the pressure till, let's say, 5 bar, something like that. And then you suddenly open the pressure, open the valve so that the pressure can expand towards the shore side. And in that way, you flush the liquid with more force towards the shore side. You can repeat that 2 or 3 times in order to make sure that a maximum amount of liquid has been purged. Then you can close the manifold valves and you can warm up the small piece of line in between the two ESD valves, the ESD valve from shore and the ESD valve on the ship side. When you warm up that part by, for example, simple seawater spraying over it, the pressure will increase, and of course, from time to time, we release the pressure to one side or the other. And then when everything has been evaporated in between that small, in between the two ESD valves, you can purge that with N2, and then you can safely disconnect. Finally, and that is really finally, you have a lot of emergency procedures where we discussed already a few of these emergency procedures. There's only one which is left, and which is, yeah, quite an important one on board of a gas tanker, but luckily I never had to use it. That is the jetsoning of cargo. Jetsoning means the pumping overboard of cargo in case of emergency. In case you have, for example, liquid on deck because you have an overflow of one of the tanks, because you have a stability problem, because you have a damaged vessel, or so on. In that case, the captain can decide for the safety of the ship and its crew to do the jettisoning of the cargo. I don't need to explain that this is an extremely dangerous operation, and that this will be only done when there is no other option. Normally, you have a specific piece of pipe on board that you can connect to the manifold in order to discharge the cargo under the seawater level, so that you pump directly into the sea and not into the atmosphere. What will happen if you pump into the sea? Yeah, you can imagine. You will cool down the sea, but especially all living spaces in the neighborhood will be killed, of course, but especially it will create a lot of dangerous vapors, because your cargo will soon arrive at the surface and evaporate immediately and create a huge cloud of dangerous vapors. Dangerous vapors related to explosivity, but maybe also related to toxicity. So keep, of course, the wind direction into consideration. This is really a dangerous operation. Should be limited to the minimum. All ventilation should be closed. The accommodation should be isolated, and preferably the relative wind direction should be from aft or from somewhere abeam. And really hope that you don't need to do this during your career. Good. That was it for this last chapter. I will come back then with the live session about the line plan somewhat later this week. Thank you very much for your attention.